Chapter 7 review, number 21. It's got 4 parts to it. So first thing, let's find the region, and then we're going to revolve it around x, y-axis, x equals 4 and y equals 4. Alright, so what does it look like? Y squared equals 4x. If I square root each side, it's going to be y equals plus or minus 2 square root of x. So it's a sideways parabola. Looks like that. There must be more to it. Let's see. Oh, yeah, so y equals x. So y equals x looks like this. So we've got this area right here, and we're going to go around the x-axis. Alright, so going around the x-axis, it would make sense. We could use the shell method, but we haven't learned that yet in this stage of the assignment. Well, actually, it's the review, so yeah, we could use the shell. But I think most people would try the washer method just because it's more straightforward. So going around the x-axis, we're going to have to figure out what big R is and little r. It will be dx because it's a horizontal axis of revolution, and we're using the washer method. So the washer would be from here to here, so let's find the point of intersection. So we can set those. I could just plug x in for y because y is equal to x. So I'd get x squared equals 4x, so x squared minus 4x equals 0. So they intersect at 0 and 4, so we know that this is 4. If I plug 4 in to either of them, I'm going to get 4 also. Alright, so this order pair is 4, 4. Alright, our big R here would be, that's our big R, and that would be y in this equation. So if you solved for y here, it's the square root of 4x, or I guess I could call it 2 square root of x, like I said before. We only have to worry about the positive, the negatives down below, but this is just y equals 2 square root of x. That's our big R. So 2 square root of x squared minus, then our little r is just this y, which is equal to x. So we'll plug x in, and we're going from 0 to 4. Alright, so I'm not going to evaluate the integral here or even clean it up. It's going to be 4x minus x squared, but that's the difficult part, the math that's difficult in this problem, I think. Okay, so now we're going to revolve it around the y-axis. So, oops. In part A, I used blue, and part B, I will use green, going around the y-axis. We can use the washer again. This will be your big R, and that will be your little r. If we have a vertical axis, it's going to be pi big R squared minus little r squared, but it's going to be dy, which means we'll have to go from 0 to 4, which is the same boundaries of integration as before, but you think of it differently, 0 to 4 with respect to y. So your big R here is x for this equation. I say x because that's always the distance out from the y-axis, is always going to be x. We can't use x in this because we're integrating with respect to y. So what's another way I could write that as x? Well, that's also x equals y, so there. So y squared minus, my little r is this one's x, So if I solved this for x, x would equal y squared over 4 squared. Alright, 2 down, 2 to go. Now we're going to go around the line x equals 4. Okay, so this is x equals 4. We have a vertical axis of revolution. We can use washer again here. Our big R will be this distance. And then your little r would be this distance. So big R is this whole distance, little r is this distance going around x equals 4. Alright, so going around x equals 4 is vertical. We're using washer, so it's going to be pi big R squared minus little r squared dy from 0 to 4. Our r is this whole part minus this. This part is x, which is equal to y squared over 4. That's what this x is equal to. So this distance would be 4 minus y squared over 4. Alright, my little r is this whole part minus this part. So this whole part minus this x, which is actually y, so it'll be 4 minus y. And that'll be that integral, if you can see that. Alright, I have one last color. I'll go with red here for the last one. Okay, we're going around y equals 4. So y equals 4 is back to the horizontal. So your big R would be this, and your little r would be that. We're going dx so it's integral of pi big R squared minus little r squared dx, so it would be from 0 to 4. I know it's dx because it's a horizontal axis revolution using the washer method. So our big R is this whole thing minus this. So 4 minus y. Well, we can't write y here because we're integrating with respect to x. So it'd be 4 minus this y in terms of x is just x. Y equals x. So it's 4 minus x squared. And your little r is 4 minus this one y. 4 minus this y, which is 2 squared of x. So it's 4 minus 2 squared of x squared. And that'll get you the volume going around y equals 4.